All right, how's it going? Today we're gonna get some practice actually writing a piecewise function. In the past, we've just been given the function and been told to graph it. Now I've been given the graph, and we are going to write the function itself. All right, so first thing I'm gonna do is I'm gonna notice that there are two parts to this function. So when I write my piecewise function, put my curly brackets, braces as they're known, and I'm going to sort of section it off into two levels. You don't need to draw that line there. I'm just drawing it so I, give myself the proper amount of space. All right, so I want to start with right here in the US of A, we like to read from left to right. So I'm going to start with this function first. And I could do a couple of things first. I could define the function, or I could write the domain of it. So I'm actually going to write the domain first because that's the easier part. So we can see that we're starting at negative infinity and we're ending at 0. So an easier way of saying that is just saying that x is less than 0. I guess you could also say that x is less than or equal to. We don't know which function exists at this point, but I'm just going to say less than. All right, now this is clearly a linear function. So to write the equation for a linear function, we base that off of our equation, y equals mx plus b, with m being the slope, b being the y-intercept. Here my y-intercept is 0, so that b value is going to be 0, and my slope is up 1 over 1. So rise over run, change in y over change in x is just going to be 1 over 1. All right, so I can say my slope is 1, x. So really, that function is just defined as x, because 1 times x is x. So when x is less than 0, the function is f of x equals x, or y equals x. The rest of my function is going to be when x is greater than or equal to 0, so right here. So again, we see the y-intercept for this function is 0, and my slope is up 2 over 1, up 2 over 1. That would be change of y over change of x equals 2 over 1. So this will be 2x. I could say 2x plus 0, but it looks a lot nicer when you say it like that. All right, so that's the function there. Actually, they don't normally close the parentheses. I guess you could. The brackets. It doesn't really matter. That's not really what they're looking for, or what I'm looking for. Good. So this next graph is hard to see, but this is shaded in here. So I'm going to do the same thing. I'm going to call this g of x. It doesn't really matter. I could call it whatever I want. Okay. So let's instead of doing our domains first, let's write the functions first. So here, this is going to be a little tricky because I can't see the y-intercept. I can see the slope, though, is up 1 over 1. So if I just follow this pattern, I actually can find the y-intercept, and I can see that's 1, 2, 3, 4. That's a y-intercept of 5. So I know whatever I put here, I'm going to have a plus 5 for my y-intercept. And like I said, the slope is up 1 over 1, aka 1, so just x plus 5. All right, now here it's very clearly an open circle. So I'm going to say this is only true when x is less than, what's that, negative 2. All right, so now when I write my domain for the next part, I want when x is greater than or equal to negative 2, so we have a filled in circle there. All right, for this function, this is a very simple function because it's just only one y value the whole time. It's always going to be equal to negative 2. All right, so that was a little quick. All right, number 9. Okay, now we've got 3 parts. So it's going to be a little bit more work. It's okay. We all love math, right? So we don't mind a little bit more work. All right, I'm going to do my domains first. I find that to be easier. So this first domain, let me just make 3 lines. Those are all semicolons. That separates the function from the domain, the rule for the function in the domain. So this first one, that dividing line is at negative 1. and we're going in this direction. So we want x to be less than or equal to -1, because those circles are filled in. The next one, x is between two numbers, so x is going to go in between our two inequalities. They're open circles, so we're not including the two values I put here. We start here at -1 and continue all the way to +1. And then my last one will just be x is greater than or equal to +1. Okay. I can see that actually every single slope for all these lines is up 1 over 1. These are all pretty simple slopes. So I can actually write x, x, and x all the way down because they all have a slope of 1. I don't need to write that 1, but I'm just showing you that that slope is 1. What they do differ where their y-intercept is. So for this first one, I'm going to follow the slope up 1 over 1, and I can see that will eventually hit the y-intercept, the y-axis at 2. So that'll be x plus 2. This, I can clearly see, hits the y-axis at 3. So that's x plus 3. And then these look very much like they're on the same line, but they're actually not. If I follow the slope backwards, it's going to hit the y-axis at 1, so that'll be x plus 1. Right. And it is pretty important that you write the domains in increasing order. So this is the lowest, this is the middle, this is the highest. So you should always organize your piecewise functions like such. All right, number 10, another one where we've got 3 different functions. All right, and you can argue that, which point here, when x is equal to -2, x equals 2 belongs to which function, since we can't tell which one. So, there could be a couple different results for that. Let's call this k of x. And I know I'm going to have 3 different functions. So I'm going to make my 3 different semicolons. All right, so for this first one, I'm going to follow the slope. So I'm just going to find points along the line so I can see what the rise over run is. And I can see them going up 3 over 1, up 3 over 1, up 3 over 1. And this is going to be a little bit tricky now. So I know the slope is 3x, or the slope is 3, but I can't see where the y-intercept is going to be. So I'm going to have to do a little bit of algebra. So y equals mx plus b, right? That's our normal formula. Well, I know that my slope is 3. I also know that this point exists on the line, right? That point is -3, 1. So I can plug that in for x and y. X will be -3, y will be 1, and we'll keep the y-intercept as b because I don't know it yet. So 1 is equal to -9 plus b. Add 9 to both sides, we get 10 is equal to b. So 3x plus 10. Great. And that domain starts all the way down here and stops at x equals -2. And let's say x is less than or equal to -2. We'll include it for this part of the function. Doesn't really matter. I could have said x is less than also. It wouldn't have been a huge deal. All right, here's a nice horizontal line. So that's just going to be equal to one single constant number. 1, 2, 3, 4. That's always equal to 4. All right. Now, this is important. When we look at the lower bound of this function, -2, it has to be less than x. X is less than, yeah. It has to be less than x, because we can't have it exist for both of these functions. It can only exist for one of them. All right, and let's have it not exist for the upper bound also, +2. All right, now I've got another function here. It looks like it's going to have the same y-intercept as this. See how they're symmetrical? I can sort of tell that they're going to have the same y-intercept. I'll still do the work at least to prove that that's true. So here we see the slope is down 3 over 1. So that's a slope of -3. And now let's just do some work to find that y-intercept, just to practice that algebra. So this point is 3, 1. So I'm going to plug that in. Y equals mx plus b. My y coordinate is 1. My slope is -3. X coordinate is 3. Let's leave b as it is. This equals -9 plus b. And we see that I was right in my prediction. that we're going to get the same y-intercept of 10. All right, so for this domain, we have to include positive 2. X is greater than or equal to 2. And that perfectly defines that function. All right, you could interchange this, right? If you wanted to, you could have put the line under here and erased it from this one. That would have been just as valid. That would have been totally fine. So there's a couple different combinations you could have gotten away with for the domains here. Okay, last one, we'll do j of x. And here I clearly see 3 functions. And this is a finite domain, right? This is not an infinite domain. The other ones had arrows at the end. This one stops, so we're gonna have to keep that in mind. Every single domain actually is gonna be x between 2 numbers. So I can organize that already if I want to. Oops, sorry, let's see what I'm doing. I can organize it like this, because as you can see, there's a min and max for each part of the function. These are super easy to write though, right? This is just y is equal to 1, y is equal to 3, and y is equal to 5. Those are pretty easy functions to write. The domains are going to be a little bit more work. So I can see at the lower bound for this first function, it starts at x is equal to 0. So I'm going to make sure I include that point 0. It doesn't include when it gets up to 2. This next function has a filled in dot at 2, so it does include that point, and has an open circle at 4, so we don't include it there. The last one is included at 4, and then stops at 6. All right, that was all for writing piecewise functions.